Every day is a new challenge, every day is a new puzzle. You're not just here surrounded by incredible research and cutting-edge techniques, you're doing it, you're a part of it, and there's just something so exciting about that.
The SURF program was founded at UT Southwestern in 1984 by one of our faculty members. And the goal was to bring bright young people onto our campus for the summer for an intensive 10-week research experience. And since 1984, it has grown. SURF stands for Summer Undergraduate Research Fellowship. Each summer we aim to bring in 100 fellows from across the nation. And this year we had an applicant pool of about 1,200 people, and that's fairly typical for us. We encourage each of the mentors to give the students a project that's as independent as possible.
We've recently started to look into different options for how we can start engineering kidney tissue to somehow overcome the shortage of organs that are available for transplant. There are about 200,000 people on the waiting list for a kidney and only 16,000 available, so the math on that is not very good.
We are currently working on developing a protocol for 3D printing tubules that are found within the kidney.
Certain students like Tess and some of the others that have come through really end up kind of getting bitten by the bug, and hopefully they will go on to doing PhDs or medical degrees and keeping on in the field.
I love UT Southwestern. Now that I'm here, I wouldn't want to go anywhere else.
When you learn about science in your classes, it's so formal, and you kind of learn it from a book. Although you may understand it, you don't really get it until you have the hands-on techniques that you learn in a lab. And that really brings science to life, and it makes science make sense.
She's not standing around with her hands in her pockets, she's actually doing the science herself. Mary's taking on a project working on diabetes and the way in which it impacts the cardiac cell, the myocyte. And that's a problem that's exploding around the world. And at the same time, she's rounded with me in the CCU at a hospital across the street, Parkland, where she's seen patients who have the very disease that she's studying here in the lab. As a physician scientist, I am extremely energized by what I do. I love my work, and frankly, the research we're doing is getting better and better over the years.
This program has opened my eyes to the potential of research, the whole idea of discovery and being able to help others. You know, because science just gives you the possibilities to do something in a lab and then affect millions of people. You know, I'd always wanted to go to medical school. I didn't know if I needed a PhD or wanted a PhD. But with this program, you know, it's opened my eyes to the possibilities and the doors that a PhD opens up.
He's already thinking about a lot of important issues that scientists have to consider for careers in science. You know, how do you make sure that experiment is right? How do you make sure that experiment is well controlled? What does this finding really mean? Our futures are dependent on the next generation, and there's all these conditions and diseases that afflict our society we have no medicines for. But then it all starts from basic research in the lab. And so to have young kids or young scientists like Nick, you can see what they've told you they've learned in class, but they don't know how to apply it. But then to be able to come in here and now work on a project and see their excitement, it just makes you feel good that perhaps we're in good hands.